Good day, folks. Welcome to my YouTube channel. Let's look at the question 2, which is a Newton's law application. It's Newton's first law. Now it says two blocks of masses 9 kg and 4 kg are connected by light inextensible string. A constant force F acting on 75 degrees to the horizontal is applied to the 9 kg block as shown in the diagram below. The string runs over a frictionless pulley. Guys, we can see here this is a system. Two objects are attached by a string and there's a force applied at an angle to the horizontal of 75, and this system it accelerates this way by a constant velocity, which is 4 meters per second. Now it says a 9 kg block moves at constant velocity. That's very important. Constant velocity means the acceleration is 0 and the F net is 0. That's very important, while experiencing a frictional force of 2.5. So there's a frictional force on 9 kg. Now 2.2, it says draw a label free body diagram for 9 kg. Now let's look at the forces that are acting on 9 kg. Since we have a force applied there, we'll have an Fx there, and we'll have an Fy like that, and we'll have a tension force in that direction. We'll have a normal, and we'll have a gravitational force there, right, and the frictional force there. Now for 4 kg, we'll have a tension, we'll have a gravitational force, right. This system it accelerates to the left this way, so we'll choose up and left as positive is our direction. Now drawing the free body diagram, so these are the free, I'm gonna do all the free body diagrams. For 9 kg, we have a normal, we have a gravitational force, and we'll have Fy, and we'll have Fx, and we'll have the tension, and we'll have the Fx, right. This is the free body diagram that is not needed. Well, you don't get marks for it, but it's helpful for the calculation. Normal force, gravitational force, and then we'll have the force applied there, and then we'll have the tension and the frictional force. This is the free body diagram that is needed, that you get the marks for it. This is 2.2, right. Let's do the free body diagram for 4 kg. The 4 kg block, we have the tension that is bigger than the gravitational force because the 4 kg is accelerating upwards. All right, guys, let's go to 2.3. 2.3, it says calculate the magnitude of the force or acting on 9 kg. So the magnitude of the force acting on 9 kg, we're going to calculate it by using the simultaneous equation. So I'm going to start with the 4 kg. 4 kg, I'm going to create the equation. F net is equal to ma, and then the forces that are acting there, we have a positive tension because it's going upwards, and we chose upward as positive. And then the gravitational force at 4 kg is going to be 4 times 9.8 is equal to, remember this is moving at constant velocity, the acceleration will be 0, so t is equal to 4 times 9.8. It's going to be, when you punch that in the calculator, it's going to be 39.2 newtons. Then we have the tension here. So now we have to create the equation for the 9 kg block as well, so that we can get the force applied. F net is equal to ma, the acceleration is 0. So we have a tension that is negative, it's going in this direction, and the friction that is negative, and the Fx that is positive. So we have a friction is negative plus Fx, right. So we substitute the tension, it's 39.2, they have the same tension, minus the friction we were given, it's 2,5 plus, and the fx is f cos, and the angle is 75 degrees equal to 0. So we're going to take the answer of these two. It's going to be okay, let's do this. We're gonna have f cos 75 degrees is equal to it's gonna be negative 41,7, negative 41,7, and then we divide by cos 75 both sides, and then we cancel, and this is going to be positive. So the force is going to be positive, so we cancel that. Your f, it's going to be, when you punch that 41,7 divided by cos 75, it's going to be 161,12 newtons. This is the force applied. This force applied. That's the answer. I hope that makes sense. Cheers. Bye.